How's it going, guys? My name is Alex, and today we're going to be talking about bubble sort. Spoiled bubble sort. Bubble sort can be also referred to as heap sort, but bubble sort, it compares two elements, and the lighter number or the smaller number floats to the top, and that's where bubble sort gets its name. And the heavier numbers or the bigger numbers tend to sink to the bottom, and that's how stink sort gets its name. As you can see in this demonstration right here, this is the smaller numbers up here, and down here is the heavier numbers, and they're sinking to the bottom. And you can see in this example how bubble sort works. It compares 5 and 3. 5 is greater than 3, so they get swapped. 5 and 1 get compared. 5 is greater than 1, so they get swapped. And 5 and 6 get compared. 5 is less than 6, so they don't get swapped. 6 is less than 7, 7 is greater than 2, they get swapped, and so on and so forth. And you can see in this picture a better visual aid to see. So 9 is greater than 4, so they get swapped. That's why there's the cross. 9 is greater than 8, 9 is greater than 3, 9 is greater than 6, 9 is greater than 7, 9 is greater than 2, 9 is greater than 1, but it's not greater than 10, so that they don't get swapped. And 10 swaps 5 because that is 10 is bigger, and you can see in there. But now let's talk about the time complexity of bubble sort. Bubble sort has the best case of O of n as n the number of elements, but we want to look at the average case, which is O of n squared, and the worst case, which is also O of n squared. The worst case is if all the numbers are flipped backwards, and the best case is if they're in the correct order. So as you can see in this, that O of n squared right here, that is the time complexity bubble sort, that's why it's circled, and it's in the horrible range, but the best is O of n, and that's in the fair range. But as you can see, the quick sort, merge sort, tim sort, and heap sort, they're either in the bad range or they're the one horrible range. But you can see that is incredibly faster because this is the number of operations, so the amount of swaps, and this is the number of elements. So for this, the more elements, it's about half the time in than bubble sort. And as you can see in this visual representation, this is bubble sort working. You can see it's pretty slow, but for the other bubble sort, if you modify it, you can make it so that it works. So that if it's completely sorted, so say that got sorted, if it's completely sorted, it will go through once, and it won't only do that, not go through it many times until it's over. So still be the same time complexity if you modified it so that it will look something like this. So say that the int numbers equals 50, 10, 30, 20, 40 in that order, and all this is saying is output to the console window. So if I put a breakpoint right here, all of that will come out of the console window would be 50, 10, 30, 20, 40. As you can see, it came out as 50, 10, 30, 20, 40. And now if we step through the code, swapped, which is up here, which automatically defaults to false, or it doesn't matter what it defaults to actually in the array, because as soon as the array starts, swapped is equal to false. And once you come here, for integer I equals 0, and while I is less than the length of numbers, so this would be 5, 1, 2, 3, 4, 5, we want to run this code. So if numbers of I, so since I is equal to 0, this is the 0th position, so this would equal to 50 right here, and if that is greater than the numbers of the position to the right of the 50, which should be 10 right now, that is, you want to do int temp. So this is equal to numbers of I plus 1. So 10 is equal to temp right now. So right here, I is equal to temp. As you can see right here in this locals window, as soon as I press F11, temp is going to be equal, temp is going to be equal to 10. So 10. Now the 10 is going to, we're in the array, so this right here is going to be equal to 50. So it's going to be 50, and this also going to be 50. So F11. As you can see, the 0 place, because C# is base 0, 50, 50, 30, 20, 40. And then, because now I'm putting back, and the right here, that is going to be equal to 10. So, and then swapped is equal to true. And it does that until I has reached the end of the array. So right here, and then because we're gonna go through and make sure that's true, and then swapped equals false, and we're gonna do this, run through it once, and then because swapped is equal to false, we're gonna break out of the array. So that's just what happened. And now if we press continue and open up the console, it's going to be 10, 20, 30, 40, and 50. Thank you for watching my video. I hope you enjoyed.